For billions of years, our solar system has been a cosmic clockwork, a masterpiece of gravitational balance. Planets gracefully trace their path around the sun, their orbit incredibly stable, predictable, and the very foundation of life on Earth. We take this cosmic rhythm for granted, and it dictates our seasons, our days, and our existence. But what if the delicate balance, this cosmic tranquility, were to be disturbed? What if in the vast, seemingly empty expanse of interstellar space, a celestial wanderer, a star, perhaps much larger than our sun, were to venture too close to our cosmic home? So, today we are going to explore the untold story of our solar system's future, a future that could be profoundly shaped by an event that will, while it's rare but far from impossible, the passing of another star. The universe is immense, and the distances between stars are staggering. Proxima Centauri, our closest stellar neighbor, is over 4 light years away, and that's roughly 40 trillion kilometers. So, the idea of another star getting close enough to cause trouble might seem far fetched. However, star isn't static. They're all moving, orbiting the galactical center. Their cosmic dances, they are like dancers in slow motion. Over the billions of years, these paths intersects. Our sun itself has had close encounters in the past, and will undoubtedly have more in the future. In fact, astronomers have identified several stars that have passed relatively close to our sun in cosmic history. One notable example is the Shoals stars, which come within zero point 0.8 light years about 70,000 years ago, practically a stone throw away in astronomical terms. While this was far enough not to cause any major disruption, it demonstrates that these events do happen. So, how close would a star need to get to truly make a difference? The key to understand the impact of passing star lies in the fundamental forces, which is gravity. Gravity is the invisible hand that shapes the cosmos, holding galaxies together, binding planets to their stars, and dictating every celestial motion. When stars approach our solar system, its immense gravitational field begins to interact with everything within our sun's domain. Think of it like two massive magnets being brought close to each other. Their field influence one another even before they touch. The, the further away the passing star, the weaker its influence, but as it draws closer, its gravitational pull can begin to tug on our planets, asteroids, and most significantly, the vast icy reservoir known as the Oort cloud. This isn't about direct collision, those are incredibly rare. It's about the subtle yet powerful long range effects of gravity, disturbing orbits of the material here in our solar system, changing velocities and potentially sending the objects hurtling in new directions. The distance of the flyby, the mass of the passing star, and the velocity are critical factors to determining the scale of the disruption. To understand the most immediate and likely impact of the passing star, we must venture to the outermost reaches of our solar system, far beyond Neptune of our solar system, and into the colossal spherical shell of icy debris, the Oort cloud. Imagine a cosmic deep freezer, a trillion strong collection of comets and icy small planets left over from the formation of our solar system. These objects are only very loosely bound to our sun's gravity. A gentle tug from passing star, even a relatively distant one, can be enough to dislodge them. When a star's gravity perturbs the Oort cloud, it can send cascade of these icy bodies hurtling inwards toward the inner solar system. This phenomena is known as the comet shower. While spectacular to behold, an increase in comet also means an increased risk of impact on the planet, including Earth. Throughout Earth's history, major impact events have linked to these, cometary influxes. This is one of the most probable and potential hazard, and it is a hazardous outcome of a close stellar flyby. Beyond the old cloud, a closer stellar encounter could begin to affect the planets themselves. Our solar system planets reside in remarkably stable, nearly circular orbit, but these are not set in stone. Even relatively smaller change in a planet's velocity or position could caused by gravitational tug of a passing star can have a profound long-term consequences. This is a butterfly effect of cosmic mechanics. Imagine a star passing within a few hundred astronomical units, still well beyond the Neptune, but close enough. Its gravity would exert a subtle yet persistent pull. This could do the following. Number one, increase orbital eccentricity, making orbits more elliptical, leading to a greater temperature extremes on the planet. Number two is tilt orbital planes, shifting the alignment of planetary orbits relative to each other. Number three is shift orbital periods, changing the length of the planet's year uh, for gas giants like Jupiter and Saturn, which hold significant gravitational sway. Even minor changes in their orbit could propagate, destabilizing the inner rocky planets, including Earth. Now, let's explore more dramatic, though less probable, outcome of truly closer stellar encounter. If a star passes within, say, 100 astronomical unit or even closer, the consequence could be catastrophic. Planet flinging, a powerful gravitational tug could accelerate one of our outer planet like Neptune or Uranus beyond our sun's gravity escape velocity, sending it hurtling into interstellar space as a rogue planet, and that will be lost forever from our solar system. Number two could be planet capture. So, conversely, if the passing star carried its own planetary system, or if there were free floating rogue planets in interstellar space, our sun's gravity could capture them, adding a new unpredictable member to our cosmic family. Orbital resonance, which is the third one, the gravitational force could lock planets into new potentially unstable orbital resonances, leading to chaotic conditions where orbits become unpredictable and collisions become far more likely. A new binary system could also form in the most extreme and incredibly rare scenario if uh, a sufficient massive star past very close and slowly enough. It could even become a gravitationally bound to our sun, forming a binary star system. This would fundamentally alter everything about our solar system, creating entirely new light and heat dynamics, potentially rendering planets uninhabitable. So, how would these cosmic upheavals affect Earth, our fragile blue planet, the only known abode of life as far as we know it? Increased cometary impact, as we discussed already. The most likely immediate threat is an increase in cometary impact, potentially leading to mass extinction event similar to the one that wiped out dinosaurs. Climate chaos can also happen if Earth's orbit become more elliptical. We would experience far more extreme seasons, which would be much hotter. You know, the perihelions will be much hotter. Aphelion, which is the furthermost, will be colder. This would devastate the ecosystem, rendering much of the planet uninhabitable due to radical temperature swings. Uh, what other thing could happen is loss of atmosphere or even water. In a very extreme case, if our orbit were significantly disrupted, or if the sun's activity were somehow affected by the new stellar companion, Earth could lose its atmosphere or oceans becoming a barren world. While these more severe scenarios are less probable in short term, they highlight the profound interconnectedness of our solar system and the delicate condition that allows life to thrive. The vastness of space is not always empty. It is dynamic, ever-changing environment where stars, galaxies, and the planetary systems are in the constant motion. The chance of star passing close enough to our solar system in the next few million years to cause truly catastrophic disruptions are extremely low. Our solar system is incredibly stable right now, and stellar flyby are rare events, uh, especially on the human timescale. However, understanding these possibilities isn't about fear mongering, it's about deepening our understanding of the universe, appreciating the incredible cosmic ballet that has shaped our existence, and recognizing the delicate balance that allows life to flourish. It reminds us that our solar system, while a beacon of stability for billions of years, is still part of a larger evolving cosmic story. And sometimes that story includes occasional, unexpected but truly impactful visits from a passing star. So, friends, thank you for joining me on this journey into the untold story of our solar system's future. If you have any comments, any points which you want to share, kindly send in your comments in the comment section below. Thanks for watching, and I will see you in the next one.